Oceanography and convection currents. The world's oceans cover almost 3/4 of the Earth's surface, hold 97% of the Earth's water, and are home to over 98% of all life. So it follows that the study of these oceans is not only important but necessary to understand the environment. Oceanography is a scientific discipline that involves the study of the entire ocean, from shallow coastal areas to the deepest trenches. It is an interdisciplinary science whose vast array of subtopics highlights not only the complexities that accompany oceanography, but the interconnectedness of science in general. Oceanography ultimately provides an understanding of the world's ocean, one of the most significant aspects of life on Earth, and reveals the processes within its entirety. Convection currents are an important aspect of oceanography and play a significant role in the sustainability of the ocean as a whole. Convection is defined as the movement caused within fluid by the tendency for hotter material to rise and colder material to sink under the influence of gravity. So in turn, convection currents are simply a continuous and directed movement of fluid caused by said heat transfer. So how do convection currents work? Let's take a closer look. Convection currents fundamentally rely on the density of water found in the ocean. Hot water is less dense than cold water, allowing it to, in any circumstance, rise to the surface above the cooler water. When a water molecule is heated, it gains energy, causing it to become more active and therefore expanded, enabling it to be less dense than cold water, whose molecules are slow-moving and compacted. For example, if you dropped an ice cube in a glass of warmer water, the melting colder water would drop to the bottom of the glass. This is due to convection currents and is the exact process that happens in the ocean. As sea ice forms, the colder, saltier water left behind becomes denser and begins to sink, making room for warmer water, which is less dense, to surface, where it eventually cools from ice formation and sinks. The cold, dense water flows along the ocean bottom, where it ultimately mixes again with warmer water and rises to the surface. This creates the ongoing current caused by convection, known as the global conveyor belt. Thermohaline circulation, thermo meaning temperature and haline meaning salinity, drives the global conveyor belt. So where does the belt go? The belt begins on the surface of the ocean near the pole in the North Atlantic, where the water is chilled, leaving salt, which does not freeze, making the surrounding water more dense, allowing it to sink. This deep water moves south between the continents to the edge of Antarctica, where the water cools and sinks again. This water then splits, one section moving into the Indian Ocean and the other into the Pacific. They then loop back southwards and westwards, eventually returning to the North Atlantic, where the cycle begins again. So what does this complex system contribute towards? Ultimately, this complicated current is responsible for the heat distribution and balance that is crucial to the ocean environment, keeping the temperature gradients of the ocean stable and not widely fluctuating, and the water in constant circulation. Also, because ocean currents circulate water worldwide, they have significant impact on the movement of energy and moisture between the oceans and the atmosphere. As a result, they are important to the world's weather, moderating worldwide temperatures. Currents contribute towards navigation, with knowledge of them essential to the reduction of fuel consumption. Additionally, convection currents can move and transport debris such as rubbish or ice throughout the ocean, contributing to trash islands or iceberg formation. Finally, ocean currents are important to the distribution of the world's sea life. Many species rely on the currents to move them from one location to another for breeding or migration. Convection currents contribute towards all these aforementioned aspects, playing an important role every day in the ocean's stability. Without the knowledge of convection currents, scientists would not fully understand the enormous influence that the ocean has on the environment or the ways in which it enhances everyday life. Convection currents are a scientific area that highlights the complexities of the world and the elements within it. It is scientific disciplines such as oceanography that open key insights into the ways in which environments stabilize and evolve. Perhaps the most important observation is that oceanography gives a worldview, an understanding of the global system that is the environment, led and manipulated by the world's vast and powerful oceans.